Is everybody there? Is everybody in the class? Okay.
Yes.
Okay. Let's go ahead with the session, and thank you very much for your patience. There was some problem with the sharing, so I had to create a new link and send it over. Okay, so as you see on the screen, we're going to start with the very basics, and I will have a day 1, day 2 coverage and have them recorded every day, so you can look at it in your free time. If you have any questions, you can of course email me or your point of contact, and we can get that sorted out. Every day before we start the class, we will have 10 to 15 minutes for discussions as to if you have any questions from the previous sessions or anything that you have as far as your career perspective is concerned. We can get that sorted out over that 5 to 10 minutes. My suggestion is to be very interactive during the class. Keep asking questions. It could be you can just unmute yourself or ask questions, and I'm constantly monitoring the chat, so if there are any questions, I'll take it up from there. But the idea is to be interactive and keep asking questions and make sure that you get the best out of this time. Okay, so although the course is about Amazon Web Services, we do have an audience where people are new to IT and still are passionate to move towards cloud computing and are carried away with the new buzzword called cloud computing. I'm sure we're going to go there in few days, but we really have to have the backbone strong. So, and hence we start with the very basics of the operating systems, networks, how they work, what are load balancing, things like that. There may be a few people who already know about this, but then for them it will be a refresher. And for those who already know, they can also pitch in and give their suggestions about how they have implemented a particular thing, or share ideas with the people. Yeah. Okay. So, any questions or concerns from anybody? Okay. Thank you. Okay, so you talk with the very basics. Like I said, we talk about operating systems today. What is a client-server model, LAN, WAN concepts. I do have PPTs which I will share eventually, but I'm not a great PPT guy being on the technical front. I love to draw diagrams and show it to you so that you can visualize things. So that's where we'll be using my favorite tool called MS Paint, which I'm sure everybody knows that. So what is an operating system? Can somebody tell me what is an operating system? Sagar?
Yeah.
Yeah. What is?
Anand.
Go ahead. Go ahead.
Yeah, Anand. Well, so when you're asking about the operating system, yeah, it's a core concept, right? So on the basis of the operating system, we install the applications, and it's like a main essential thing.
Mm-hmm.
I'm not a good good explain. I don't have much explanation about that, but when it comes to the part, I know
I
the
understand.
operating system is like a base. Yeah.
That's fine. Well, I appreciate your effort, coming out and unmuting yourself and talking. That's important. Yeah. Yeah. So that's a good motivation factor for everybody. It could be right, it could be wrong. You may not be explaining properly, but the idea is to come out of that shell and interact and talk to people, share your ideas. That's what it is about. So yeah, thanks, Sagar, for your inputs.
My
Well,
pleasure.
an operating system is kind of a app software that manages your hardware. We cannot talk to the hardware directly. We cannot talk to the software directly. So what we need in between is an operating system that talks to you. So I, as an end user, will need an operating system to talk to the hardware. Let's say that's your hardware, and it's got magnificent amount of resources, lots of resources, right? Hardware can also be written like this, right? And let's say it's got good resources. Let's say 8 GB of RAM with a Xeon processor, yeah, maybe a couple of terabytes of hard drive. That's good. What's the fun if you're not able to talk to it? An end user is sitting here, is not able to talk to it. There is no point. So what you need in between is an operating system, and this could be any operating system. This could be as good as DOS as well. DOS is just a command line. So if I open start run and CMD and hit enter, that is nothing but a DOS prompt, right? And here I can communicate to the networks, I can communicate to the operating system. And even this is an operating system, it's the shell, right? So what you need is an operating system that will communicate with the hardware. But even more important is another layer called as, well, that's not a good picture. Another layer, what we call it as drivers. Yeah, you of course need drivers to communicate with your hardware. So it's you who communicate with the operating system. The operating system communicates with the driver, and the driver communicates with the hardware. And then it gives it back. The hardware communicates with the driver communicates with the operating system, and the operating system gives it back to people like you and me, right? So that's where we are able to even talk today, right? I'm talking to the application called GoToMeeting. GoToMeeting talks to the operating system. The operating system talks to the drivers, the audio drivers, the mic drivers, and then the hardware, and then it goes out, right? So for every hardware that you have in the machine, now I want somebody to list out the hardware that could be on your machine, and I'm going to write it down here. What are the different components of your computer that you have, that you're using? Anybody? Or I will pick and choose somebody. That's how the class is going to be. We have to talk. Yes, Sagar. I see you unmuted yourself.
Uh, I mean, like it's a very simple question.
Yes.
I mean, so nobody's answering, so that's the reason I just unmuted.
Thank you.
Well, so now it comes with the first monitor, and the monitor is a display, like it gives the output,
Good. Okay.
and the keyboard is the input,
Mm-hmm.
keyboard and mouse, and the CPU is like which is working
Uh-huh.
under the controller. So what are the inputs we are getting? The CPUs also did some operations inside, and it gives the output in the monitor. So this is like so regular
Good.
general process.
Great. Shilpa, can you add to this? Do you find any other hardware on your computer? Okay. Well, what we also have is a hard drive. What we also have is RAM, which we also call it as memory. RAM is called as memory in computing world. There are certain other devices like keyboard, and there's a mice. Then there are peripheral devices as well as printers, maybe a graphics board, right? There's so many of them. Audio, video port, and you know what? None of these function, the list that we have here, none of these will function without a driver. We need a driver at any cost. So it's a driver that communicates with the hardware and the operating system and gives you a particular output. No driver, or even if the driver gets corrupted, it's not going to function at all. Right? So that's the kind of infrastructure that we have, and this is regardless of the operating system that you're using. It could be Linux, it could be Unix, it could be Solaris, it could be Windows. Windows comes with various flavors that we'll see in a while, and it could be DOS. There are more operating systems with Internet of Things, IoT, that you might have heard of. There is Raspberry Pi, there is Ubuntu, so many of them. Then everything needs driver to communicate with the hardware. Driver is not working, it's not going to work at all. Yeah. Moving forward, what we're going to see is a client and server model, right? Now, keeping this entire system apart, let's draw something called as a server. We call this box as a server, right? And then we'll also see something called as a client, which could be as good as your laptop, or it could be another server, right? It could be your own laptop that you're using now, or it could be a laptop that's in your corporate environment, right? Now this is what we call it as a client. Now keep in mind that we are using the client server model even now. I am using the server of GoToMeeting to talk to you. I'm also using the server of my internet service provider to get the internet. The GoToMeeting server is giving back information, and then I am taking information. So I as a client will talk to the server, and server talks to the client back. In order to retrieve information, it could be put information or getting information. So what we call it in IT is called as put and get, right? It could be putting information or either getting information. In either case, whoever is a receiver is the client, whoever is a sender is a server. Keep in mind that client can also be a server. What if I just remove this and keep another server here? Two servers can be communicating with each other. So whoever is the receiver is a client, whoever is a sender, in this case, whoever is giving information to another point of contact is a server. Taking information is a client. Now, talking more about operating systems, there are different kinds of operating systems, and the world has divided operating systems into two parts. You will have client-based operating systems, which you can install on your laptops, anything that can be used as a client. Another part is server-based operating systems. The client-based operating systems, let's talk about Windows first, and then I'll talk about Linux or other operating systems. Client-based operating systems, as you know, we got Windows 7 and Windows 8 that we're using now. But the way it started is from Windows 3.5, then we got Windows 4, and it was all called as Windows NT. Then came Windows 4, 4.5. But then what changed the entire world as far as IT computing and operating system is called is Windows 2000 Professional. This is from the client side. Microsoft has changed the GUI, the entire algorithms behind Windows 2000 or the Windows operating systems. Then they introduced Windows 2003 and came Windows 2003 R2. Oh, this is actually server based. We'll write that on the other side. Then this is Windows XP. But in between Windows XP and Windows 2000, what we had was something called as Windows Millennium. Yeah, that was called as Windows Millennium. Then after Windows XP came Vista, then Windows 7, and then down, you know, anything after this like Windows 8 and then Windows 10. It's gonna never stop. Keeps on moving. Yeah. And server based, you got the similar set of operating systems. You got Windows 3.5 to 4 to 4.5, and all of this come under the new technology family. Then Windows 2000 here again, but from the server side they introduced Windows 2003, then Windows 2003 R2, then Windows 2008, Windows 2008 R2. It's all an evolution. They keep on creating operating systems, and what eventually we get is new set of features. We as end users or customers request Microsoft to create a new functionality, and they incorporate in the new operating system. So there we go, Windows 2016 as well. That's how it is. What to keep in mind is that each of these operating systems have flavors within them, right? Like Windows 7 has a home edition. It also has a professional edition, and then it also has Media Center edition. What they will get is new set of features. If you purchase Windows 7 Professional, you can take it to corporate environments. But if you take Windows 7 Home, you will not be able to use in corporate environments. You cannot join into the domain. Similarly, for server-based as well, you get several flavors within each of them. Like there is standard, Windows 2008 standard, Windows 2008 R2 Enterprise, and Data Center Edition, Core. There are multiple operating systems within that. So there will be Windows 2008 R2 Standard, Windows 2008 R2 Enterprise, Windows 2008 R2 Data Center, and Core. And then Windows 2012 R2 12 will also have each of those flavors. Any questions so far? Hello? Any questions?
What is this R2 indicates?
Release 2.
Oh, okay. Thank you.
It's a new release. It's a totally different operating system. Although the name may appear to be the same, Windows 2008, Windows 2008 R2, the name is almost the same, but if you install it, then it's going to be totally different GUI. I will have you install each of those in your virtual environments. So moving forward in about maybe third day or the fourth day, when we talk about virtualization, there I will ask you to create your own virtual machines and then install one of these operating systems and get a look and feel of it. Yeah, you have to do that.
What is the difference between client-based OS and server-based?
There are certain features that you cannot use in client-based operating systems. Like if I have to host a website, you have to install a software called as IIS. You will not be able to install it on client. If you have to use it as authentication server, then we have to install something called as a domain controller. Then that is something we cannot install on client-based operating systems. If you have to, get a email exchange facility in place, create your own email exchange facility, that you have to install something called as an exchange server. You cannot install that on Windows client. Then, and that goes on. There are a lot of features that server-based operating systems provide, which client-based cannot. Client-based are primarily used for computational purposes, accessing the servers and accessing the resources, whereas server-based can give all those resources. It can be used as a file server. So there are a lot of new features that this guy can give you.
Okay, thank you.
Great. Any other questions? Okay, great. So that was about operating systems. Let's talk about a little bit about networks. So we're talking about LAN and WAN. Oh yeah, I forgot about telling about non-Windows operating systems. There are other non-Windows operating systems as well. From the client side, you got Mac, sure you're aware of that. Linux also comes for client-based or desktop-based. Um, there's an edition from SUSE called as SUSE Linux Desktop Edition. It's primarily for desktops, and there are others as well called Ubuntu and Fedora. And one thing is that there are certain operating systems that can be used for both client and server. There's Red Hat Enterprise, Red Hat also comes for client operating systems, and there is Solaris, there is IBM mainframes, there are lots of others as well, not just Windows. There are specifically certain operating systems that come for ethical hacking purposes. It's called as Linux Kali. This is only for penetration testing and hacking purposes. There's another operating system called as Linux Backtrack. That is also for ethical hacking purposes and to penetrate into someone's environment. There's an operating system called IoT, which is called as Raspberry OS. Microsoft also comes with IoT operating systems, so they call it as Microsoft IoT. So the list can keep going on. People have created their own operating systems for optimization and performance reasons. Okay. Let's say you are within a building. You're inside this building, and I'm sure you have seen offices somewhere where everybody is connected with their computer, and those computers have LAN, local area networks. So LAN means that if your communication packet is not going out of the building, and let's say that is an exit point, we call it as a router. That's what we call it as a router, right? That is an exit point. So that is a building in which you have multiple computers. There are tens and tens and hundreds of computers. All of these computers talk to each other, right? All of these computers talk to each other, and they have good network connectivity between them. There are thousands of computers inside this building, and as long as the network traffic does not go outside from this router, they are inside something called as LAN. It's called as local area network, right? That means the traffic is local to this building. So you got Wi-Fi at your home, you got a bunch of devices connected to those Wi-Fi routers, and there are other people who are also connecting, like your family members or your friends, or somebody is connecting to that. All of you are in a local area network. The moment the traffic goes out of the router for internet access or file share access or whatever, it goes out of the router or the Wi-Fi device, it then enters into something called as WAN, which is wide area network, right? Wide area network can also be between two buildings. Wide area network can also be in between two buildings in two different geographical regions, or even in the same geographical regions. The point is that they are going out of the router and connecting to another router. The moment the traffic goes out of your network, of your LAN, and then hits the router, it goes out for certain purposes, then it is called a wide area network. When it is inside your building itself or inside that office itself, it's called as local area network. Any questions? Any questions? Silence is golden. Okay. Shiva, any questions? Sagar? Shanti? Moving forward, you got client and server models, which you are aware of now, client and server based operating systems. How does the data flow within the computer? Let's say that was day 2, Shanti. You're only talking about day 1. We did not talk about IP addresses. We don't know what IPv4 and IPv6 is. That is day 2. Subnet masking. Tomorrow we'll do a lot of networks. So that's where I'll tell you what VLSM or variable length subnet masking is. So CIDR is classless interdomain routing, but let's not go out of the subject. That is day 1, which is today. Day 2 is this. I will have a everyday agenda for you. So yeah, thank you. So how does the data flow within your computer? How does it happen? Let's say you are sending an email to somebody and the person receives it, and even you are transacting certain information within your computer. Let's say you're processing an Excel sheet or processing a PowerPoint, then how does it happen? How does the processing happen in your computer? Right? Anybody knows? Okay, so let's say that's your computer, and computer has several parts, as you know that, right? That's the motherboard. Motherboard is the most basic um, infrastructure that you need within, or component that you need within your computer, without which nothing is going to function. Let's say that's your motherboard, and on your motherboard there are several slots. The slots could be RAM. For the RAM, let's say there are several pieces of RAM. Usually there are 4 slots for the RAM, and you can put 4 pieces of RAM inside that. Then there is something sitting on it called as a processor, and then of course there are cables that you can connect to your motherboard. Your cable you connect to your motherboard, and then you connect it to something called as a hard drive. Yeah. What else? There is a graphics chip. There is a CMOS chip. CMOS stands for common metal oxide semiconductor. CMOS. Yeah. So there's a CMOS chip out there. Now there are several chips. The graphics chips. There's a LAN card chip. There's the audio port. There are USB connectors to it, and then there is HDMI, firewire port. There's so many things that are connected to the motherboard. But eventually, what you have to see is an output on your monitor. If you do not see an output on the monitor, then it's going to be no fun, isn't it? So you gotta see that output. So the only way we can see the output is if your motherboard is functioning properly, right? So let's see how that happens. Well, that's not a great picture of the monitor, but let's try to fix it. Okay, that's better. Now, what happens is when you double click on a file, or when you open a PowerPoint file, right? Like even in this case, I have so many files open. I have a Chrome browser, I have Notepad, I have GoToMeeting, MS Paint, and so many things out here. Yeah. So the way data processing happens is as soon as when you click on a file, could be any one of these, it just comes and sits on the task manager, right here in the task bar. What it also does is that, let's say this is the memory. This part is the memory. What it also does is that it leaves a footprint in the RAM, right? It just goes to the RAM and creates a small executable in the RAM. So it is consuming, let's say, some percentage of your memory. If your RAM is, let's say, 4 GB, it may be consuming 1%. Let's say GoToMeeting is consuming 5% of your memory, or my DOS is consuming 0.5 MB of the memory. So it goes and resides in there. the way you can see what are all the applications that are eating up the memory or even the hard disk is by just going to the task manager. This is important, yeah, for troubleshooting purposes. You have to right click and go to task manager, and here you will see the bunch of processes that are running. Another one is called as services. Both of these are important. So here you see the list of services that are running. Here you see the list of processes that are running. So each of these processes have consumed how much? This notepad has consumed almost 1248 KB. MS Paint has consumed 22 megabytes. Chrome has consumed so much. So you can see which one of them is consuming the most in your memory. So I'll just sort it down by the most on the top. I just click on this and I see that Chrome is consuming almost 120 MB of RAM, right? In that way, you can also see which one is consuming the most CPU. As the task manager itself is consuming 21%, 22% of the CPU, whereas this one is consuming 48 MB. So that way you can narrow down which one is consuming most and maybe also try to kill it. Right? This Chrome is open now right here, right? If I click on end process and say end process, Chrome will be killed. It will not be there on your task manager anymore. I think there are more Chromes. Let's see. Yeah, there's one more. Let's try to end process and say end process again. Okay. Is there some more? There are a lot of them. Let's sort them by name. We've got so many Chromes. Yeah. Although I have just one tab open. Again, end process, end process, end process, end process. So that way you can go ahead and kill them. Eventually I can just continue to do this, but that way you can kill these items on the task manager. Take a look at the task manager when you find time. There are a lot of things within this. Explore all of these task manager and try to understand what they do. If you look at the performance concept, performance component of it, it's telling you what is the CPU usage, what is the memory utilization on your computer. It's got 2 GB of RAM, page memory is this, system handles are this. So I would like you to take a look at all of this. So your homework for today is to take a look at task manager and see what each of these tabs mean. What is it that you can do with this? What are the options, files, and try to understand each of these today. Task manager. Getting it? So your homework for today is task. Okay. So there are lots of components inside this. So what I was telling is when you process the data, when you double click on the Chrome or media player or Excel, anything for that matter, that particular component resides in the memory. It will take certain component of the RAM and it resides there. And then it is also processed by your CPU. So whatever tasks that you're doing are queued up. They are actually queued up in the processor. So you might have seen the components of the CPU. One is the speed. Speed people tell is it okay 2.5 gigahertz or whatever, right? But there is also something called as a cache. Cache is there is level 1 cache, there is level 2 cache, L1 cache, L2 cache, and certain high-end machines also have something called as level 3 cache, right? Is this helpful to queue the processes that are running on your machine. Let's say you got 20 applications that are open like this. On the taskbar you see 20 applications that are open. Now everything must be processed by the processor, isn't it? So they stand in queue, and to stand in the queue what they need is space. Space where? They need space in the processor itself, and that space is provided by cache. So L1 cache could be 2 MB, L2 cache could be 512 MB, L3 cache could be certain KBs. Anybody has a question, or did I confuse or was not able to explain properly? Sagar?
Please repeat once again, sir.
Anybody else? Anyone else? Okay. So, when you launch your applications, like your Chrome or Excel or Internet Explorer or anything, they will have their footprint in the memory. And then it has to be processed by the CPU. And everything that I am writing here on the notepad, it's only possible because the CPU is processing my keyboard strokes, right? I am typing something on the keyboard and the processor is processing my keystrokes and putting them in the queue, because there are a lot of things happening in the computer parallelly, isn't it? The audio is being processed, the video is being processed, the screen share is happening, the audio drivers are functioning, and all of these are being processed parallelly, isn't it? And hence they have to be queued. It cannot be done simultaneously. We have only one processor. You don't have some multiple processors. So they have to be queued, so that queuing is nothing but like standing in the line. So if you go to ATM, there are 4 people out there, you have to stand in the line. You want to buy a ticket in the subway or railway station, you have to stand in the line. You want to go and buy a pizza in a subway, you have to stand in the line. This is no different. There are hundreds of processing that's happening in the computer, and the processor cannot do everything, all of them at once. They have to be queued, and in order to queue, you need to have space, right? So in a subway, there is no space. You cannot stand in the queue, isn't it? You will just stand somewhere outside if there is no space. In an ATM, if you have to stand, you need some space. Similarly, all these processings that are happening in your computer needs space, and that space is provided by L1 and L2 cache, which is there within the processor. So the processor also has memory apart from the RAM. So every binary that is being executed, every application that is being executed sits there in the memory, and then it has to go to the CPU for processing. And in order to process itself, it has to stand in the queue. To stand in the queue, it needs memory in the CPU. Any questions? Hello?
No, sir, it's clear. Thank you.
Okay, that's good. So that's how the processing happens, and this processing is no different for client. Client also processes in the same way. Server also processes in the same way. Cloud computing, the servers and the cloud computing also process in the same way. It's no different, right? Okay, so when you're choosing a server, when you're choosing or maybe procuring a new server, then you have to make sure that these configurations are properly selected. Server must have L1 cache, L2 cache, or the processor must have L1 cache, L2 cache, L3 cache. The RAM should be good, the speed should be good, multiple core processor. So take a look at those components as well. So I would like you to, tomorrow when I come in, or when we start, I would like you to give me, this is another homework that I want to give you. So choose the best, choose not the best or anything, choose a server for high-end and computing. What I need from you is what processor will you choose, what hard drive will you choose, and the amount slash kind of memory. Memory is nothing but RAM that you're going to choose. Okay? So that's your first homework, to know about the task manager. And the second homework is to tell me, if you have to choose a server for high-end computing, what kind of processor will you choose, what kind of hard disk will you choose, and what kind of memory will you choose. Any questions so far? You'll not have any questions under two such circumstances. One is when you understand everything. Second is when you do not understand anything. So, Sagar?
Anand, is like a Windows servers or like a Linux-based, Unix-based server? You, you asked me to pick the server, right?
Right, right.
Like, I mean, tomorrow's, yeah, it's like Windows-based server or like you're talking about the Unix-based server.
Great. Thanks for your question. It could be anything, Sagar. It could be Windows. I'm not asking to choose an operating system here, but just the hardware that you can select and let me know. And maybe, yeah,
Okay.
yeah. You don't have to choose an operating system, but just the hardware. I just want to see your understanding, and then we will discuss more on that when you choose a particular hardware. And if I find some interesting points to share with by looking at the hardware, I'll definitely go into it.
Okay. Thank you.
Okay. Thank you. Shiva, any questions? Okay, Shanti says Windows. So yeah, it could be Windows, Linux, or anything, but it's more about picking up the hardware. Operating systems, you can pick up anything, but I want you to pick up some hardware. Let's Google around what are the various vendors in hardware, Intel, AMD, Gigabyte. There are so many of them. Pick up one of the best and see what you can give me as far as if you want to give me high-end computing, a good processor, a good hard disk. And when you are looking at that, also look at the speed. Hard disk configuration, just it cannot be 1 terabyte. That is not sufficient. The RPM, which is called as revolutions, rotations per minute, like 15,000 RPM, 17,000 RPM. For high-end computing, you will have a 1 terabyte hard disk, but maybe 1 terabyte hard disk with 9,000 RPM is not sufficient. It will not solve the purpose. So you have to pick up something that is higher in terms of rotations per minute. Now, when you talk about RPMs, the days of RPMs are gone. Right? RPM is a old jargon now. People are no longer using um, HDDs. People are using SSDs. You find out the difference between them. Solid state disk. Difference between solid state disks and HDDs. So give that a shot. The only thing is that when you're researching about it, you will find lot more jargons. You will see a lot of things. So make a note of that, ask questions tomorrow, and first 15 minutes I want it to be more of a discussion. Don't be silent, come out, and you will memorize these kind of jargons only when you talk. When you are silent, these things will be in the mind, but when you are in an interview, these jargons will not come out. So if you talk now, you are actually preparing for an interview. Okay, with that we call off for the day. I apologize for the audio issues that we had in the initial. Tomorrow I'll test it and then send the links. You should have the links in about a couple of hours and you can take it out from there. Make a note of everything that we are doing today. Make a note of all the questions that you have when you're doing research, and tomorrow is the best day to talk about that. Tomorrow we'll go into a little bit of networks, what are IP addresses, IPv4, and if time permits, we'll do virtualization as well tomorrow. Thank you very much for your time. Unless you have any questions, I'll stay here. Wait, thank you. Thank you, Shanti. Thank you, Sagar. Okay, thank you. Thanks, everybody. I'm disconnecting the session. Thank you for your time. Bye-bye.